Oh,
All right, you guys see that all right?
yep.
All right. So I'm going to talk about event sourcing and CQRS. So what is CQRS? CQRS is the Command Query Responsibility Segregation. That's what that stands for. And basically, that's just a pattern for separating your read and write operations. And that's really just the whole premise of doing CQRS is just creating that separation of current concerns between the two different things. So let's talk about those commands and queries. So a query, which would be your read operation, just returns the data, but doesn't do any altering of the state of that data. And your command, which is your write operation, does change the state of the object, but doesn't actually return anything. So if you can think of your typical like CRUD service here, at the top, let's say we have this location service, and that has this mark a location as preferred and get a location. And so that's how your kind of your typical service that you would see. So if you were going to apply CQRS to that, you would split that up into two different services. So you have your write service for mutating the data there, mark location preferred, and then you have your read service, which is actually retrieving the data. So if you look at just kind of a workflow for that, you'd have your read data store, and so that would return that through your service layer up to the user interface, and then if they were going to mutate that data, then you would be sending that command, which your command object is just like a simple basic object. It's not a complex object, and so that command just flows back through your right side of the service to update the data store. So that's kind of the idea there. And put framed that way, that's not terribly interesting, right? So the idea is that but doing that enables you to do some pretty interesting things, and so we'll get into what those things are. So kind of the first question is where do you put CQRS? Like, where do you apply that pattern? And Greg Young, one of the big proponents of event sourcing and CQRS, he emphasizes that CQRS is not a top level architecture, meaning that you're typically not going to be using CQRS in your as a like user interface design pattern. It's really more used for the server side or like application server kind of thing. So a top level architecture for that for your type of application would be more like service oriented architecture or event driven architecture, meaning like messaging and queues. And for us, we use in most of our stuff, we use the event driven, the messaging and queues kind of architecture.
Coupled with our query handlers, right?
Right.
Which is kind of an intentional CQRS in most of our systems, where you have your queries through one code path and your commands through a different one using the service bus.
Right. Yep. Yep. So, implementing this, or I shouldn't say implementing, but using this CQRS pattern, this enables you to do what they call in domain-driven design this task-based UI. So, and this is pretty different than CRUD in that with CRUD, typically, your create, read, update, delete, that kind of shapes how your application is built. Whereas tasks are more user centered. And so, like, let's say, example of a task would be like submit an application, reserve a seat, join a quest. So those would be kind of example of tasks, versus like, edit a product or something like that. So as I said, those tasks are a little more user-centered. And so domain-driven design, that kind of requires this task-based design. And so CQRS can help you move towards more of a domain-driven design approach to software. And one thing that is kind of emphasized too is that you don't have to necessarily be doing CQRS to have a task-based UI. It just helps you accomplish that goal a little bit easier. So that's kind of the basics of CQRS, and I want to talk about event sourcing now. But to really talk about event sourcing, we kind of need to talk about domain-driven design a bit more, because a lot of the concepts that are used with event sourcing and CQRS really drive from this domain-driven design. So, and this is...
Hey, Joe.
Yeah.
Do you mind if I ask a question here?
Sure.
It's one I have some thoughts to of what the answer is, but I think it'd be worth discussing before you leave the topic of CQRS. What, in your mind, are some of the advantages or proposed advantages of having that separation of command and query? Like, what is that buying you when you do separate them like that?
Right. So, and I have a diagram a little later on.
Oh, okay. Sorry.
But no. I probably should have had that earlier on, because that's a great question. So basically, and maybe I can actually move back up here, and I probably should have mentioned it here. So because, so in our diagram here, we have that separation from our, write area and our read area. And so typically the number of reads in your system far outweigh the number of writes. And so what that can enable you to do is you can spin up a lot more servers, possibly even more databases, or even, just other objects in memory that enable faster reads. And so you can, scale your application based on the reads, separate from your writes. So I think that's one of the biggest things that it enables you to do.
Yeah, I agree. The ability to scale each side independent of each other. Even when writing the code, you can write code that's very specific to how you want to read without potentially tainting it with code that's for the mechanics of writing. If you tried to use like a repository pattern or something like that, and you're trying to think about reads and writes, it allows you to specialize and say, well, this code path is only for reading, so I can optimize for that, and I can scale individually based on that. And I think that can be powerful to focus in, and it allows you to explore things like, is there a way to do some caching? Does caching make sense? And not have to worry about the repercussions of writes. And there's many, and like you said, multiple databases. If you want, you could do a different database thing. So it gives you a lot of flexibility to mold it to what your needs are.
Yeah. And it makes it a lot easier to create multiple different views on top of that data as well, because you're typically not using the same model for your writes and your reads. And so you can, you're not kind of stuck in that one model kind of scenario.
Yeah.
Yeah.
Thanks, Joe.
Yeah, no, that was a great question.
Love that custom set.
Yep. That costs extra. That's an upgrade.
Okay.
So domain-driven design definitions. Say that 5 times fast. The So first one we want to talk about is the domain model. So the domain model just captures the domain knowledge from the domain experts, and this just kind of enables the team to kind of have a common language and determine what you're going to talk about, what you're going to work on, and just that everybody has a consistent knowledge of what those what you're going to be working on and the consistent language. So, and typically this domain model is expressed in code by the developers. And kind of as I said, having the common language word you often hear is this ubiquitous language. So you come up with that when you're talking to the domain experts, and this allows you to identify nouns and verbs when talking about that business process. So, for instance, a quest is a noun, and start is a verb. And so you can like start a quest, join a quest, leave a quest, and these are what the things that kind of become your tasks. So we talked about that task-based UI, and so these are the things when you're talking with your domain experts to come up with this language, then that kind of becomes this ubiquitous language. Entities, value objects, and services. Entities are defined by a unique identifier that is always constant. And conversely, the value objects, if all the properties on an object are the same, then those two value objects are the same. It's not based on the unique identifier. And services are typically, like a third-party service and don't hold state. So a little more interesting ones, which I think as developers that you would usually be working with, are these aggregates. So the aggregates are just a group of related entities, value objects. And the important part about that is that they form this consistency boundary within the system. So that consistency boundary is usually based on this transactional consistency. So basically, if something's going to change within that aggregate, we want to make sure that if there's multiple different changes, that all of them happen within the same transaction. And I'll clarify in that doesn't necessarily mean like a distributed transaction as you would maybe think of it in like database terms, but just that it's just consistent. So you can talk about aggregate roots, and so an aggregate can contain other aggregates, and so an aggregate root is this gatekeeper object for that group of aggregates. So all access to the other aggregate objects happen through this aggregate root. And so all external entities or processes, they can only they can only reference this aggregate root instead of, like a child object directly. And that just helps maintain that consistency throughout the system. So so working with the aggregate, what would that kind of look like? Here's an example, like command that we would maybe be handling in the system. So here's this members joined command. And so we can load up the aggregate based on its identity. And then we can call a method or function on that aggregate and pass it the data from the command. And so notice that the command just has these value objects basically on it. And so those command objects are just basic DTOs. And then one way to work with that is then you kind of have a repository type pattern. So you retrieve it, call this method on the aggregate, and then save that aggregate back to the data store. And I'm going to talk a little bit more about some different things that can happen in that save function in a little bit. So another concept here we have is bounded context. And this one's a little more abstract, but this is a grouping of domain models that ubiquitous language, entities, all those things within the overall system. So you may have a larger system that has multiple bounded contexts. So an example of that may be a large conference management application. And so that could have a conference reservations, which would have a orders aggregate, a payment aggregate, like a seat reservation aggregate. And so that would all be in one bounded context. And then you may have a separate one, like a program management bounded context, which has kind of its own ubiquitous language for that part of the system. And that may deal with speakers and sessions and things like that. So you just kind of use the term bounded context to just kind of bundle up all of those things into kind of big silos. And then a context map, that's just the documentation that describes the relationships between those bounded contexts. Like for instance, in that large conference application, so you have your people who are coming to the conference, and then the sessions, and obviously there's got to be some communication, perhaps, because you may have to sign up for a specific session or something like that. So there may be, some communication between those things. All right, so back to a little less abstract here, and kind of the one of the things that I think is one of the most interesting parts. So events. Getting into the event sourcing here. So events are just notifications of something that has already happened. And that's kind of a key takeaway with events, is just kind of describing that something has already happened. And these are immutable one-way objects, and they're published by a single source, but could have multiple subscribers. So for instance, if you think of a write operation, you could be writing to a single data store, but then you may have multiple different views or view objects or query objects that may be interested in that data that changed. And so down here at the bottom, you can kind of see just like a really simple example of maybe code that would look like building an event. So here in our document store, we're just going to append an event here for a specific aggregate. So there's the ID, and this is the book seat event, which just has the a name and the seat. So as I kind of talked about, they typically include like information, basic information about the event, and kind of the idea is to describe the business intent. So, in that previous example, it would be like, CE23 was booked by Quinn, versus, kind of like database talk, talk about tables and key values and things like that. And the really interesting part is that, you can take this simple description and kind of use that to kind of see what happened in the system. And I'll show you an example of that here. So this is kind of the idea which I talked about a little bit, which was, so we kind of have our same read pattern here for the query side of things, but on the command side now, instead of just having the basic command go into the system and write to the data store, you can have these event messages, and that can populate to your different read side of things. So talked about that a little bit, but so just a reminder that those aggregates define that consistency boundary, and so you can use the event raised by the aggregate to notify those interested parties that a transaction has taken place. So those other interested parties know to, they may need to do something. And kind of talk about this too, that the ID is, the source of the event. So the ID of the aggregate. So, and this is the really neat part, is that you can take all these events to determine your current state of your application just by looking at the history of the events. So you can replay that event stream to get your current state. And probably the easiest way to think about this, I think, is like a bank balance, right? So you have your initial balance, then you make a couple deposits and a withdrawal, and then you have your end balance. And so, the kind of funny thing to think about is that, your bank balance probably isn't a column in a database, right? So your bank balance is determined by, all the previous transactions that happened in your bank account, right? And so that this is kind of one of the reasons to use event sourcing is that, if you're writing a banking application, you probably just don't want someone to be able to go and say, update table balance equals 1 million, where user equals, 5 or something, right? You want to be able to kind of have that, essentially kind of like audit log of, like things that happened in the system. So let's kind of look at the data flow again of how a command can go through the system and work with events here. So here I have this command, which is for a particular entity here, and just has some basic data. And And so we saw this before where, so this comes through our command handler here, fetching the entity, calling the method, and saving the aggregate. And so then you could use your repository pattern here instead of, like saving that complex object to the data store. You can say, hey, aggregate, give me all of the events that are currently uncommitted. So when you go and you're calling this function on the aggregate, all that's doing is just creating an event and keeping track of, all the events that happen. And then when you're going to actually persist the data, you just say, hey, give me a list of all the events that have happened since, I was last saved. Is that making sense?
Yeah.
Cool. And so one other pattern I've seen here too is that instead of going through that process of fetching the aggregate and working through it that way, I've also seen people advocate just creating the events directly and appending that to the event store directly as well. So that's kind of an interesting idea. And right now, Martin, this is what Martin currently supports right now, if you were going to use that today. So,
are you talking about some of the event sourcing stuff that Jeremy built in?
Right, yep.
Is that the PG events stuff, or is that actually in Martin?
That's in Martin.
Oh, cool, okay.
Yep, that was just brand new stuff that he released just like last week.
I think he took some of his learning from PG events and kind of brought it into Martin a little bit, because people have been saying, hey, this is a good fit for that as well.
I think he did.
Some of the community members.
Yeah. So I thought that was pretty cool. Kind of an interesting thing to think about. So what does an aggregate look like? So how does that aggregate know how to handle that data here? So I created just this little simple application in JavaScript to do all this. So like here's an example aggregate. Here just showing it has a couple properties, the ID and a name, and then this is just wiring up a handler saying I know how to handle this quest started event, and so just wiring up the function to that specific event, and then when it's going to process that event, then it just is getting it is assigning the name of the quest from the event data. And so that's how it is, just wiring up the handlers, basic handlers, and then here is how it's loading up the past history, so replaying the events. So you just have a function on that object which takes in a list of events, and then just calling this apply change on the object. And that apply change basically is just going through that list of handlers and matching up the function to call based on the event name there. So that's kind of the basics of that. And let's see that in action.
Yeah, you gonna show Lord of the Rings?
Well, we are gonna create a quest here. So just have this little node app, and I actually need to.
The one ring.
I want to have a quest for the Holy Grail.
Yeah. Well, that is not the sample data here, so. No. Look. This is we can even do that.
I'm joking.
See, look. The Holy Grail. The quest has started.
Nice.
So if we look down here, I'm just printing out some information. So we got a command to add a quest, and that was the Holy Grail. And through that process, that kicked off this event, saying that quest has started with just a little description here. So if we add the other quest here, so we have the One Ring, and so one thing to think of is that this data that I'm displaying right here is a just a read view based on the events that are happening in the system. So like this list of quests is just based on these events. So that's kind of something interesting to think about. So now I'm going, here's the details of my quest here. So the current status, you can think of that, here's the current state. It started, and here's my quest log. So I want to add some members. And so now my current state is, hey, the quest One Ring is at Hobbiton on day 1 with Frodo and Sam. But then I still have my log of events that are happening. So I can go on and add a couple more members. So Pippin and Merry. And so now my current state is at, I'm on day 2 in the Shire with now these 4 members. But again, I just kind of have this quest log of stuff that has happened. So let's kind of look at that here. And again, I guess if you look down on the console here, this is probably maybe a little small. So maybe I should bump that up a little bit. But this is just data transfer objects. Just very simple objects that are going through the system. And so I think that's one of the powerful things about this pattern, is that you're working with just really simple data. So if we look at our index here, so I called that view, that read view, this quest list. And so and I'm using React here. So when this component loads up in the system, then I'm just saying, hey, stream all of the events in the system to this quest list object. And so what that does is essentially that's going to call that, load from history that I showed you before. And this quest list, it just cares about these specific events. And so when it encounters those events, these methods are going to get called. And so this is just has this basic list on here, which is keeping track of, the event ID, the version, and the name. I shouldn't say the event ID, but this is like the aggregate ID, I guess. And then when members are joined, I'm just updating the version here. So if you go back to the this list here, there's this 1 and this 3. And so this is just indicating that this quest is at like version 3. So that's one thing to know of, is that typically you version your aggregate. So your aggregate has versions 1, 2, 3, 4, 5, and so that the interesting part is that you can say, well, load this aggregate at version 3, right? And then, or you can say load this aggregate at version 12, and so that creates really interesting scenarios, because then you can work with your data at kind of this known version or this known state. So that's I think that's a pretty powerful thing to think about, especially for testing, right?
And another use case for that is, say you have a bug in your code where, or not even necessarily a bug in your code, but you also, there's a piece of data that you thought would be important to track, but you didn't think about it at the time that you were writing some feature, but the data is there on the events. You can change how you source your state based on the events.
Yeah.
And then now the next time a command comes in, that code can source its current state to a new, better type of state, either with the bug gone or with this new piece of data that's now being tracked by the aggregate. And you can make more interesting decisions now. And you didn't have to, with your typical, typical storage or in memory, where you get your state, whatever my current state is, it's just in a SQL table. You can't do that unless you have some way to go back and recalculate that old data. But since it's based on events, your state can be sourced by events, and it's just your code that reacts to the state can now be smarter or better or enhanced. And you can do some interesting things like that. So you can actually fix bugs, and you can throw away current state and resource it based on fixed stuff at a later date, which can be a powerful concept if your domain needs that.
Yeah.
If that's a useful thing to your domain.
Yeah. Yep.
Something else that the version was really helpful for is optimistic concurrency as well. So if you end up having multiple people manipulating the same data at the same time, you can see what version is actually on the aggregate versus what the next event is that they're trying to add, or it hasn't yet become an event because it hasn't happened yet, but making sure that they're actually on the latest version of the aggregate before applying the event to it, or if it has since increased in version, that they refresh and pull down the later changes of that sort of thing
before they make their change.
Yeah. Yep. Yeah. That's a great. Yeah. Those are two great things about it.
And these are things that, and I think this is I think the stigma with this pattern is that you can go full bore and say, well, I need all the things. Mm-hmm. And Greg Young would tell you, no, you really should work up and iterate towards some of these concepts. Like if you don't need that, don't go to the next level. Don't go to full event sourcing if it's not something your domain could benefit from. Wait till you can benefit from it before you kind of evolve into that type of pattern.
Right. Yeah.
And it's easy to over-architect with this pattern.
Yeah. Yeah. So you could be using CQRS and still get all the benefits of, scaling up your system, and enabling, if you needed to do event sourcing, but you aren't doing it yet. So.
And this is a lesson we've learned the hard way.
Yeah. Yeah.
You mean going full bore into it without needing to?
Yeah. Actually, Joe's presentation here, and you're probably not done, Joe, but your presentation here has given me some thoughts about where LAC might have gone off the rails a little bit, and I think it was not having a fundamental understanding of some of those DDD concepts that you talked about.
Right.
I can see very clearly where the aggregates were not modeled with some of those DDD concepts in mind. I think many of the problems we've had have been because we didn't understand what an entity is, what a value object is, what a service is, what an aggregate and a root aggregate are, and what our bounded contexts are. It's been interesting to in retrospect look back and go, that might have made the modeling of our objects a lot smarter.
Yeah, and kind of as I said before, like when I was hearing those things previously, yeah, my eyes would glaze over a little bit and be like, what are you talking about? But really getting into this and looking at it, it does make, it makes a pretty big difference of how you design your system, thinking about those concepts for sure. Yeah, I've had some of the same concepts just thinking about some of the wizard stuff, right? Like, how we could have architected things a little bit differently, with this kind of more simplistic. So in ways, this is a lot more simplistic what we did with the wizard, and how it would have been easier to add some of the features that we were asked for if we were doing something more, along this line.
Yeah, a lot of our problems in LEC stem from not having references through aggregate routes, or not having good consistency boundaries, or just ownership of this aggregate owns this data, so this other aggregate should not also own this data.
Right.
That's where a lot of our problems come from.
Yeah, we had the same issue on one exchange, for sure. All right. So this is kind of a read view. So don't have too much more time, but if we look at the add members, it's kind of the same idea. So we're getting the target aggregate ID just from the URL there, and then creating a just simple object and just executing this command. And this is from this quest commands .join, and that's just a simple text, so that can be shared there. And so the idea is that would get pushed out to your possibly like over a service bus, through messaging or something like that. And so I have all this just running on the client right here just for simplicity. Didn't have time to do a full-blown thing here. But so then here's the command handler, and just kind of what I showed in the slides here. Right. So handling that command, and then just going to the event store here. So that's kind of the basics of that. And then have a few more slides to get to. A couple more important concepts, I think, that are really helpful in this scenarios. So with event sourcing, they have what you call snapshots. So you can think of in a large system, those a number of events could be. That event log could be really, really big. So they have this idea of what they call snapshots, which is I'm going to build up my aggregate to this known state, and then I'm going to persist that known state in a snapshot. So, and what that allows you to do is you can load that snapshot, and you don't have to process all of those previous events. So if you have, an event stream of, hundreds of thousands of events, right, that's going to save you a lot of processing time. And so you can just load that snapshot and any future events, versus the whole event stream. So that's a pretty powerful concept with that.
One key aspect of that is that they're also disposable.
Right.
At any time, it's just a performance convenience, but they're also thrown away and regenerated at any time.
Yep.
Especially if you've got a bug in them or something.
Right, yeah. That's what I was going to say. If there's a bug, or you want to change that, how something was processed. Like one example I heard of, which was pretty good, was, let's say you have like orders or something like that, and you want to go back and retroactively give people's like points for previous orders or something like that. You could go regenerate that aggregate and calculate the points, that person has earned or something like that. So the other big thing is these sagas, and I don't know if I completely get all of what sagas entail, but because there's kind of like two different competing ideas. And so to me, at least with from some of the things I was reading, there seem to be people have kind of like two different concepts there. But the one I'm going with here is sagas are kind of coordinators, and they can coordinate the messages between those bounded contexts and aggregates. So these sagas are in charge of managing these long-lived business processes, and again, kind of we talked about, that's kind of this alternate to using the big distributed transactions, and so you can avoid locking on resources, so that you can get your really fast reads and not be too worried about locking on there. And one thing that also someone pointed out, and this is getting cut off a little bit, but your saga doesn't have to be this big thing, that lasts for months. It could be just like a few seconds, and but in the computing world, several seconds is, that's a long time, right? So computers can process things pretty fast, and so just a few seconds is, that can be a long time.
It can be useful for any type of state machine where
Right.
you need the messages to come in a certain order, or even if they come out of order. Yeah, so you've got that state machine there. But even if they come in out of order, but just seconds apart, you can say, well, whether I get this one or this one, as long as after I get both, then I can do something now.
Right.
After I have both events, I have all the information I need to make a decision.
Yep. Yeah.
So like the two people turning the key to launch the nuke.
They could be asynchronous. Yeah.
Right.
That's
Yeah.
Yeah. So as Mike mentioned, it's the sagas. They're for managing the process, not business logic, and they're usually implemented with state machines.
Yeah, I'm glad you mentioned that a long-lived transaction. That's a really good way to describe them.
Yeah. And so just kind of maybe make this a little bit more clear, and this is a little fuzzy on my screen. Hopefully you guys can see it. Okay. But so it's like, here's kind of an example of without using a saga. So a customer places an order, and that goes with this order aggregate. And this order aggregate says, oh, well, I need to make this reservation for the seats. And it says, okay, well, after I make the reservations, then I need to, process the payment. And so this order aggregate is it knows about all the other aggregates, right? And so that order aggregate is currently in charge of dealing with that process. So the idea is that, so instead of having the order know about that, you create this saga. And in where I got this diagram from, the book, they choose to not call these sagas, but call them process managers. So that's why you see this on here. And so instead you have this order saga, and that is in charge of dealing with the other aggregates. And so your individual aggregates aren't aware necessarily of the other aggregates in the system. And so what this gives you is one place to go to for that processing logic. Kind of as we talked about, it makes it easier to deal with that long-lived transaction kind of stuff. So you could possibly persist the state of this saga, so that if that takes a few seconds to process or a few months, it doesn't really matter. And then it also makes it easier to introduce another step in the process, right? You don't have to go, oh, well, now I have to go touch 3 different aggregates to just add this one step to the process. So that's kind of the idea I got from what sagas are. All right, so just kind of some of the reasons to use CQRS, and we talked about these a bit already. So the scalability we talked about, so number of reads versus number of writes. It can reduce the complexity. So we kind of talked about this too, where the read logic can usually be a lot simpler than the write logic. And when you're dealing with those two things, you don't have to worry about like messing up one or the other, right? Because they're in different places. And Mike mentioned this too, just so that you can have you can optimize the data for the read to like try and increase performance. And so if you're working with different models there, you can tweak that model however you want. So that's pretty cool. So flexibility, you can just add a whole bunch more views on top of that data because you're using a different model. And it kind of helps you focus on the business. So instead of the CRUD stuff, you're doing the user task-based things. And so what are some of the ideas to use event sourcing? I talked about the audit trail. So you can kind of see what happened in the system. Because the events are immutable, you don't really have to worry about threading as much, right? So you don't have to worry about people trying to mutate that state through multiple threads. And because they're just simple objects, it can be a lot easier to understand that simple object than a big, complex object. And we talked about this too, that future down the line, you can maybe figure out some additional business value from those events because it's just a simple event and it's not really tied to anything specific other than that particular event history. So you can go in and add a different event in the event stream and see how that affects the data, affects the outcome. And talked about this a little bit too, because it's just these simple objects can be pretty easy to test. So potential barriers. This is probably the biggest one, the learning curve, right? Some of these concepts can be hard to understand when you're first looking at it. I know it definitely was for me, for sure. And the other thing is stale data. So some of the wording people use is eventually consistent. So you can kind of think of if you're having these bunch of views that views on top of the data and multiple different databases or views on top of that data store, then everything may not be in sync right away. And so depending on your domain, that could be bad. So I think in most systems, having a short delay is probably acceptable, but that is something to think about. And reasons to avoid event sourcing in CQRS according to UD. So simple domains. So if this is really simple stuff, CRUD could work for you. So use CRUD. And the UD even says not even moving to like a 3-tier architecture, just a 2-tier architecture. You have your UI and you save data directly to the database. So that's according to UD, right? And non-collaborative environments. So if you don't have a ton of people editing the same data at the same time, and you have potential for lots of consistency or concurrency issues, then you won't necessarily need to use event sourcing and CQRS. And if you're not going to have to like spin up a whole bunch of servers to support all the users you have, you maybe don't need it. So those are some ideas to think about. So that's pretty much all I have. So where I was getting a lot of my information was this free Microsoft book by the Microsoft Patterns and Practices group, exploring CQRS and event sourcing. So that has a lot of good info. And then, of course, Greg Young. So Greg Young has a really simple intro project to event sourcing up on GitHub. and that's all done in C#, not this newfangled JavaScript stuff. So there's that, and there's also an event sourcing project, which I think LAC uses.
Yep.
We use the older version of the framework, but yeah.
Okay,
Each
gotcha.
version, not just older.
Okay, gotcha. And that's available on GitHub as well. So if you want to really dive deep, they have that whole framework there. And there are several videos of Greg Young on YouTube. This is just one of them. I watched like a couple of them, and they were pretty much the same talk. So if you find one, you probably found all of them. But so there's a link for that there too. And then also on our file share, I think there's a good like 6-8 hours or something of Greg Young videos as well. Jonathan Oliver has a really good blog posts on sagas and event sourcing. And Jonathan Oliver, he's a Utah guy. And at least last I saw, he lived in Utah. But and so that's a good blog post. And then of course, I kind of mentioned it, Martin is getting some event sourcing stuff. So it's kind of interesting to look at how they are currently working with that. And my little stuff is up on GitHub too. So
speaking of that newfangled JavaScript thing, I imagine you probably saw a lot of parallels between event sourcing and Redux.
I was going to ask the exact same.
yeah, there are similarities there. Yep. Yeah, and well, it's pretty much the same idea, right? Just event sourcing, because you have your simple objects and you can replay those in history or back them up. So it is literally the exact same concept, just on the client versus the server. So just like the whole flux pattern idea, they're all solving kind of the same problem. And it's actually kind of, when you're looking at it, it's actually kind of hard to see the difference between them. It's just a little bit of code implementation changes is what it really seems like to me. So.
Yep, definitely.
Yeah.
Yeah. Nice job, Joe.
Thanks.
Yeah, that was really good.
Joe, I learned stuff.
Yeah, well,
Just so you
that's
know.
good. That's
You
good.
didn't learn stuff. Presentation was successful.